The first step in fine-tuning an LLM with Rlhf is to select a model to work with and use it to prepare a dataset for human feedback. The model you choose should have some capability to carry out the task you're interested in, whether this is text summarization, question answering, or something else. In general, you may find it easier to start with an instruct model that has already been fine-tuned across many tasks and has some general capabilities. You'll then use this LLM along with a prompt dataset to generate a number of different responses for each prompt. The prompt dataset is comprised of multiple prompts, each of which gets processed by the LLM to produce a set of completions. The next step is to collect feedback from human labelers on the completions generated by the LLM. This is the human feedback portion of reinforcement learning with human feedback. First, you must decide what criterion you want the humans to assess the completions on. This could be any of the issues discussed so far, like helpfulness or toxicity. Once you've decided, you will then ask the labelers to assess each completion in the dataset based on that criterion. Let's take a look at an example. In this case, the prompt is, "My house is too hot." You pass this prompt to the LLM, which then generates 3 different completions. The task for your labelers is to rank the 3 completions in order of helpfulness, from the most helpful to least helpful. So here, the labeler will probably decide that completion 2 is the most helpful. It tells the user something that can actually cool their house, and rank this completion first. Neither completion 1 or 3 are very helpful, but maybe the labeler will decide that 3 is the worst of the 2 because the model actively disagrees with the input from the user. So the labeler ranks the top completion second and the last completion third. This process then gets repeated for many prompt completion sets, building up a data set that can be used to train the reward model that will ultimately carry out this work instead of the humans. The same prompt completion sets are usually assigned to multiple human labelers to establish consensus and minimize the impact of poor labelers in the group. Like the third labeler here, whose responses disagree with the others and may indicate that they misunderstood the instructions. This is actually a very important point. The clarity of your instructions can make a big difference on the quality of the human feedback you obtain. Labelers are often drawn from samples of the population that represent diverse and global thinking. Here you can see an example set of instructions written for human labelers. This would be presented to the labeler to read before beginning the task and made available to refer back to as they work through the dataset. The instructions start with the overall task the labeler should carry out, in this case to choose the best completion for the prompt. The instructions continue with additional details to guide the labeler on how to complete the task. In general, the more detailed you make these instructions, the higher the likelihood that the labelers will understand the task they have to carry out and complete it exactly as you wish. For instance, in the second instruction item, the labelers are told that they should make decisions based on their perception of the correctness and informativeness of the response. They are told they can use the internet to fact-check and find other information. They are also given clear instructions about what to do if they identify a tie, meaning a pair of completions that they think are equally correct and informative. The labelers are told that it is okay to rank 2 completions the same, but they should do this sparingly. A final instruction worth calling out here is what to do in the case of a nonsensical, confusing, or irrelevant answer. In this case, labelers should select F rather than rank, so the poor quality answers can be easily removed. Providing a detailed set of instructions like this increases the likelihood that the responses will be high quality, and that individual humans will carry out the task in a similar way to each other. This can help ensure that the ensemble of labeled completions will be representative of a consensus point of view. Once your human labelers have completed their assessments of the prompt completion sets, you have all the data you need to train the reward model, which you will use instead of humans to classify model completions during the reinforcement learning fine-tuning process. Before you start to train the reward model, however, you need to convert the ranking data into a pairwise comparison of completions. In other words, all possible pairs of completions from the available choices to a prompt should be classified as 0 or 1 score. In the example shown here, there are 3 completions to a prompt, and the ranking assigned by the human labelers was 2, 1, 3, as shown, where 1 is the highest rank corresponding to the most preferred response. With the 3 different completions, there are 3 possible pairs: purple-yellow, purple-green, and yellow-green. Depending on the number n of alternative completions per prompt, you will have n choose 2 combinations. For each pair, you will assign a reward of 1 for the preferred response and a reward of 0 for the less preferred response. Then, you'll reorder the prompts so that the preferred option comes first. This is an important step because the reward model expects the preferred completion, which is referred to as y sub j, first. Once you have completed this data restructuring, the human responses will be in the correct format for training the reward model. Note that while thumbs up, thumbs down feedback is often easier to gather than ranking feedback, ranked feedback gives you more prompt completion data to train your reward model. As you can see here, you get 3 prompt completion pairs from each human ranking.